Okay, question number 20 now, or 21 rather. Question number 21. We're looking at two charged particles. They're P and Q. They're moving in a magnetic field. There's uniform flux density, so it's the same strength of magnetic field in both of them. And we're told they've got the same charge, but one of them has got a smaller mass. In fact, the mass of P is less than the mass of Q. So let's write that down first of all. The mass of P is less than the mass of Q. And what we've got to work out is how the time periods relate. So how long does it take for these things to go around in their circular paths? So the time taken for one complete orbit is going to be equal to the distance divided by the velocity. And you'll be remembering that speed is distance divided by time using the formula triangle. So we're going to end up with time is distance divided by velocity. So the time taken is going to be equal to the distance divided by the velocity, and we're just going to come up with a general equation to tell us how long it's going to take us, and then we can see how it's affected by the mass. So the distance it's going to travel in one circle is going to be 2 pi r, of course, isn't it? 2 pi r, and then the velocity is phi. Now we're still none the wiser, but luckily for us we know the radius of a path, or a circular path, for a charged object in a magnetic field. It's given by the equation R equals, and we have the two lowercase letters at the top, mv, and the two capitals on the bottom, vq. That's in the textbook, the derivation for that. It might just be easier, to be quite honest with you, to memorise that definition there. Comes in quite handy. So we're going to shove this thing in here. So instead of 2 pi r over v, we're going to call it 2 pi, and then it's going to be mv over bq. Ooh, this is getting messy. Divided by the velocity. Now the velocity comes up here and here, so we can get rid of that straight away. So it's going to be 2 pi m over bq. So let's write that so it's not quite so horrible. 2 pi m over bq, and now it's pretty straightforward to see how the time periods are going to be affected. The time period is proportional to the mass. So if we've got the mass for P is less than the mass for Q, then the time period for P is going to be less than the time period for Q. That would be written as time period of P is less than, whoops, that should not be the case at all. There we are. Time period of P is less than the time period of Q, and therefore the answer for that one is going to be C. So it's 21C.